Okay, let's start. My apology for the delay. So good morning. So this is the third meeting of Nakuja internship. So I hope, yeah, actually I have visited your team yesterday, and I confirmed you're doing well. The progress is good. So yeah, it is much appreciated. Now, let me start the meeting. So let me open the minutes. So this is Nakuja third week on 8th, which is today. So just announcement. So I understand that some of you, or maybe one of you, have made a purchase, and I confirmed you uploaded the receipt, which is good. So please follow the instruction I have given when you need any purchase. Okay. And if you have any receipts with you, please submit it to me as soon as possible. Yeah. Okay, and let me start from confirming the progress. I mean the presence. So Anne, Innocent, I think, yeah, his apology. Some Tinega, yeah. Lawrence, Marine, yeah. Francis, Paul, Collins, yeah. Lyle, yeah. Jones, yeah. Ruth, yeah. Safa, yeah, she's apology, yeah, received. Edwin, yeah. Beth, yes. Beth, not present. Jen, yeah. Faith, here. Shabak, and Bruce, and Shanza. I think he has left the team, most likely. So let me, yeah. Okay, is anybody else present? Yep. Edmund. Oh, okay. I need to add you. Yeah, I think you were initially here, but I'll check. Yeah, yeah, here. So you are Ricky's team, right? Yes. Yeah. Okay, so let me go to the progress report, and I have checked the task sheet and some of the Gantt charts. Yeah, and yeah, mostly you did it well. So maybe yeah, I think based on this task sheet, we can hear the presentation. So this week, can I request the recovery team to proceed the progress report? Recovery. Yeah. Jones. Did you, is it this? Oh, this is airframe. Have you uploaded something? GitHub. Let me check. Internship. It's slow. Recovery team. Actually. Let me share. Oh, by the way, please put some information on the minutes and recovery. Oh, okay, you are doing it. It's okay. Okay, please proceed. I make it full screen.
So good morning.
Okay.
This is our for last week. And we had the Wi-Fi connected, the mention that it should be testable. And we also had enough set and design and the electricity connection between the ground and the computer by the supervisor. The test we were to do was actually to test the maximum range of connectivity between the ground and the flight computer. Unfortunately, we didn't manage to do this because we didn't have the antenna. Actually, James tried to communicate on the same, but we didn't get a reply. But that's how we've actually done the code and everything, so we actually just looking for the antenna.
Okay.
So,
Right.
so for the electricity connection, we managed to come up with a code to connect both computers, and we also managed to send the data from the flight computer to the local server, then from the ground computer, then and then from the local server. And also the code is working with the data report that is the link for the same. Yeah. So there are around much and design. Also, this is another one that we were also doing, but then we didn't have the other. So we have actually everything ready and it's in place. So we're just waiting for that and then we go from it. Yeah. Then
Okay.
Yeah. So we also discussed the redundancy scheme. So we've actually come up with a plan to work with 3 gyroscopes and 3 algorithms. So they'll be picking values and we'll be picking the median value so that the right data will be processed. Then the advantage of this is that if one fails, we have at least one value to work with. So at least we are sure that we'll be receiving data from at least one sensor. So in case one fails, we have the other one or the other to be picking the value.
Maybe can I ask some median value? So for example, could you explain the details?
Yeah. So each of them, okay, assuming we're using the gyroscope, so we have 3 of them. They have all their values.
You have 3 pieces of gyroscopes.
Yeah.
Okay.
It's actually in the we see the image of the PCB design after. So using the 3 values, then take the median. Then work with that.
I see. Okay. You have photos?
Yeah.
Okay.
So you can see the 3 as the 3 guys. So that was good. That was the design. And maybe the next is also another. That's the same.
I see.
So next injection computer now. So we start and thought. We were relying last time on only one thing, or rather only one signal from one source to do the injection. This time we don't want to be part of that, so we have to be sure that at least a signal has been sent for the injection of apparatus. So we are into switching modes effectively, so that in case one does not receive the signal, the other will push the signal for injection. And with this, at least we are sure that the ejection signal will reach and there will be destruction will be there. Yes. So the design is also been done. So it's actually yes.
Okay. Maybe later I want to see the circuit diagram or schematic. Yeah. Because I want to check the connection of these 2 MOSFETs.
So those are aspects of objective now for this week. Now that we need to see the antenna we were working on. We already started actually the rocket tracking using the GPS and also the overall manual operating system design. And then now that you're here, you can actually access the antenna, so you can compute the references and also the antenna. Yeah.
Okay. Okay. Thank you very much. Yes, I was just curious how this two MOSFETs redundancy works. So you are saying that if one channel is not working, the another channel or MOSFET can take over.
Yes.
And trigger.
Yes.
So
we have two MOSFETs. So we have the injection. There's a MOSFET, the primary MOSFET is supposed to eject. It ejects, there's a flag in the code that says that the injection has been done. So after a few seconds, as we descend, we can check that flag again, whether the primary MOSFET will eject. It was ejected, then it's not problem. But if it wasn't, the second MOSFET has to
excuse me, how to detect the failure, the parachute or ejection?
Ejection.
What kind of sensor are you using to detect, to identify if it's not working?
Either we are exploded or not.
Right.
We are not that experience.
Oh, okay. So you're saying the secondary MOSFET will always trigger after a few seconds.
Yes.
Okay.
Just check the primary one.
Yes. Okay. Okay. Yeah, we will continue the discussion. Yeah, for this one. And this one. Let's say you have 3 gyroscopes or any altimeters, and the first altimeter says it is 3.1. Second says it's 3.0. The third one says it's 2.9. So the median is 3.0. 2.9, 3.0, 3.1. Okay. So, I understand. It's not an average, right? It's a median. I was wondering because if the one sensor fails, like it becomes 3.1, 3.0, and 0, something like that. So, but in that case, you can still choose the median. I'm wondering, is the computation, I mean, does it affect? Because you have to always check the median value and use it for the computation. Does it affect your computation loop? I mean, in terms of computation frequency, speed, does it affect?
For checking the median, that large. So just checking the values, which one is better than the other position, then from the largest to the smaller, check the median. So that should be a problem for the line of the solution.
Okay. Yeah, line is of course is small, but you need to check the cost of the computation. Yeah, it doesn't matter even if it's short, it may affect. Yeah. But I think the comparison is not so expensive computation, so that would be fine. And antenna, yes, I agreed with June that we are able to give you this afternoon. Yeah. Okay, fine. Thank you very much. Now I try to check something. So you have described what we have done. Okay, that's fine. Now let's go to the task sheet, and you're working on. Okay, maybe you can indicate once it's done, you can strike through using this one, like this. Yeah. So that we can see what is remaining jobs. Okay.
Yeah.
And is it? I think it's also reflected on the GitHub. Yeah. Project, right? Yeah. So did you create a Gantt chart?
Yes, it is. This different option. This Jira. However, it is limited and we can't actually see the aspects of the currency. So we are just left for this.
Okay, okay. But you can still take a screenshot and share it on, yeah.
It was part of last week's, it was
a part of last week's report. Maybe, yeah, I want to see it now. So let me go to, I think you uploaded something last week.
Yes, recovery team.
Recovery team, yes, it's coming. Oh, this. By the way, maybe you may consider it's because recovery team / week 1. Yeah. Then you mentioned somewhere.
Yeah, you can download it. Okay.
Oh, no issues. Yeah. Oh, this one. Maybe screenshot. So I want to check how far you are. So now it's only January and February. Do you have something on March, or are you going to complete everything in February?
Our current design will be them as low extreme, so we will do them as much as we do by the end of the day. And then we will then revise elements.
Okay.
We will need to strategy, then we can which what modality is
Okay. So from this timeline, I can see the 3D design of pyrotechnic is already completed. And familiarization with parachute, this one also completed.
Yeah.
And okay. Oh, my question is, I didn't hear anything about parachute design, fireboards, rocket tracking, those things. Do you have any update on this? Okay. 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 The reason of creating this, it's a kind of promise. Like I'm going to make a presentation on this week and this week and this week. So you can always modify this Gantt chart, but I strongly encourage you to follow on this plan, initial plan. Yeah. Okay. Yeah, I think that's it. Any issues, concerns? It's okay. Yeah. Edwin? I think. Yeah. 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 Sorry, I was checking your message, but it's gone. My thread. Yeah. But anyway. Okay, so let's move on to the next group. Yeah, let's say airframe. Airframe. Yeah.
Good morning.
Morning.
So the last group objective is that we can analyze on the CAD design, then calculate estimates of parameter design, the drag, the load, the parking load that the airframe will handle, and make design selection. So we had, each one of us had come up with a design. So we wanted to know which one was best out of the ones that have been given. That was given from the open socket simulation. So we tested each parameter that has been used with the open socket, and then now we came to a final result. So the things that I have to be finalized, it would more or less they have been finalized, more than need to make a conclusion on what publication techniques will be used. So we had thought of getting an aluminum sheet, since one of our airframe models was fabricated using aluminum. But then that came as a question of how smooth will we mold it to like be circular perfectly. So then the next one was instead of the sheet, we get aluminum rod and then we machine through it to make the tubular shape. So we have those two. And we need to finalize the DOM so that we can start fabrication probably next week.
So you're saying that you're going to purchase aluminum cylinder, then drill or bolt. It sounds very expensive. Aluminum cylinder like this. Yeah. And I'm not sure if we can clamp such a huge and heavy aluminum cylinder. So the issue is the precision.
Yeah.
Did you check how the other teams are doing? I mean the
previous course were using
fiberglass.
Yeah. But in terms of aluminum, I think this is a new So yeah, we haven't really gotten around how we go about it.
Okay, I strongly encourage you to study more about the sheet publication, because I don't think it's feasible to create. Okay, it's feasible, but it's very expensive, takes time, and yeah.
I think that like aluminum tube that maybe.
Yeah, aluminum tube, yes. Not a cylinder, yeah, it's a tube. Yeah, that could be an option. So you have to see the available aluminum tubes. Yeah. Okay, yeah, please proceed. Yeah.
Why did you choose a meaning for what maybe the fight that looks to go for you trying to use okay, we take just use designs that you are going to use fiberglass and so are going to be very out of aluminum. So we're going to compare them during the initial design, and then the final design, you know, between the two of them, which will be the best design. We chose aluminum because, as we saw through open rockets, the rocket will be with the motor given the propulsion team is approaching Mach 1. So we thought that aluminum, it has a higher strength, very heavier, the strength is high, so it can withstand the high forces as it approaches Mach 1.
And just to add, another motivation to use aluminum rather than fiberglass was the challenges the previous team had with the fabrication and the molding of the fiberglass. They said it's somewhat difficult to achieve a smooth surface, which has a massive impact on aerodynamics. And also another thing was the post-machining of the fiberglass tube, because we need connections for the launch tab and the antenna and such. And with fiberglass, the fabrication will be more difficult.
Yeah, the surface. So the environment for the fiberglass needs to happen. Maybe an interaction levels, or maybe that is my interest. Maybe I can follow and see how the calculation can.
No, okay. Anyway, did you upload any design sheet, design documents?
Yeah, we have put the card.
Yeah. So to model a 3D model, you need to have a basis of the figure. I mean, the thickness. For example, for aluminum, maybe it's 1 millimeter. For fiberglass, it's a 2 millimeter, something like that. Because by comparing, because mechanical parameters differs for aluminum and the fiberglass. So the dimension, or basically the dimension will be different for each.
Our part, obviously was finalized on the design, so we already done that. And we already started with the design. The concepts and steps have been uploaded to general. So anyone will give their input on what changes should be done or any concerns with regards to the thing. Next slide, please. So these are the dimensions that we settled on based on our simulations in open bracket. So our total length initially was around 170, but due to the increase in the motor sizes for the propulsion team, we had to change our dimensions again to be able to post the motor that had been given to us. Because of now the airframe length is at 185.5 centimeters, that is our margin for that increase from the other one, which is around 50. Also, the node from is 25, then the tail tube and the motor mount amounts to 75 centimeters. We have overhang on the tail tube. On the tail tube, the motor that has been given to us was around 70.5 centimeters. So we tried to account for the movable part being outside. The avionics bay was 80 centimeters out of now. So the avionics bay tube. So we have the from the avionics team, they have the ejection, the parachute. So it amounts to approximately 40, and the avionics bay is also 40 centimeters. So 10 meters is 80 centimeters. And inside the tube, you'll see the next slide, we have couplers. So you have couplers separating the three body tube to prevent the motor from coming back into the avionics bay, from going to the nose cone, which is going to have couplers in between those. And for the avionics bay, so that we can assume the tubular body, since the frame itself is tubular. Cylindrical, it's cylindrical, and the avionics bay has compartments to allow the teams to put the PCBs and the electronics. So we gave it a coupler on top so that it can assume the shape of the cylindrical shape of the airframe. Next. The current designs and photograph files have already published in GitHub for vision and take any design phase. Next. So this is the airframe. This is how essentially the airframe looks like. So we have the nose cone. The middle part is divided into two internally. We have where the unit bay is hosted and where the parachute ejection mechanism will be hosted, and the last part is where the motor will be hosted.
So, where is avionics, around here or here?
Yeah. Next slide.
Next slide.
Next slide.
Oh.
Right.
Hmm.
So that's okay. The last part. I'll start from this way end. So we have the motor mount there and the pin. Then the white one. Those are the couplers to prevent the motor from going in. Then the next one is the avionics bay. Yeah, the other space that is yet to be filled is where the parachute ejection mechanism will go, and the nose cone.
Okay, I see. Maybe, yeah, maybe a question to solid team, but motor. What is the diameter of the motor? Solid motor. 75. Length? 7. Again, the diameter is 75. The length is 735. 73 centimeter. Okay. All right. Yeah. Okay. Thank you. We can just proceed.
So this is the avionic bay.
Next slide.
I was looking for it. Okay, let me just try and explain. So the avionic bay we have 3 compartments. So from the upper side in the middle there is a compartment, and on the lower side there is a compartment. So you can place PCBs or relays and stuff. Its height is about 35 mm, which is being able to accommodate the component well. On the side, the running stream says they need 2 batteries, so I give them a slot of placing their batteries. So we wanted to house the batteries on the side. However, increasing that length will cause an interference with the airframe. So we then decided instead of actually giving it a housing, we need a reed of some sort or a cable of some sort. They will place their batteries there and for them to place maybe with I think the test will do. And then to since from the ones that have been done, the remnants of the rocket, so the electronics were damaged and stuff. So we thought of maybe enclosing the gate with a shock absorber, something like styrofoam, but we haven't come to an actual conclusion of what material we will use to prevent the electronics from breaking in, being damaged during launch and during defense. Yes. Or that the airplane. So here we have the calculated estimate of the design parameters. So that entirely we're basing our calculations on the open rocket simulations that we did with the motor that was given to us. So we calculated the compressive load, the bulking load, and the drag force. So the airframe as of now can handle 60 kilonewtons. And from our calculations, the compressive load was about 700 meters. So that is the thing it's lower. So we think that the rocket will be safe from compression load during flight based on this calculation as of now. Then for the bulking load, we estimated it to be around 700 kilonewtons. However, that might change simply that just estimate. We haven't and the propulsion thing is changing the measures every now and then. So simply we are adjusting that as we do the simulations and see where we finally end up at.
How about the buckling load, which is expected? Could you estimate? So, from your calculation, okay, let's say for the compressive load, how much is the safety factor?
For now, I use this.
1. Are you sure? Because you are saying rocket tube can handle 60 kilonewton.
Yes.
And actually compressive load is only 700.
That's what I'm saying. For the when computing the maximum, just we didn't include the safety factor in the flow calculations.
So okay, what I want to say.
Yes.
So from this only this information, you are saying that your rocket is way too robust against the load, isn't it? So it meaning it's over engineering, because a rocket should be light, it should be thin, it should be kind of, skinny. So I'm wondering. Oh, but is this only for the avionics bay?
No, this was a tube.
Tube, yeah. So that's why I'm saying you need to calculate maybe again to check if you can reduce the weight of the rocket tube. Yeah. And for this buckling load as well, because is it still necessary to handle 770 kilonewtons, right? Yeah. Make it light. Okay, go ahead.
So the drop coefficients that we estimated was at 0.5, and from the open rocket simulation, we got about 0.64. So the margin is not big when you think about it, but then we'll keep doing improvement and maybe it gets shown. So from the design, our rocket had an average of 28 or 9 meters, which is more or less both distance are targeting 2 kilometers. So we are, I think, at a safe margin.
Okay. Yeah, as I pointed out, maybe you can still reduce the weight of the rocket. I think it's going to be above 2,800. So I'm wondering, so this maybe the motor is too strong for our application. Maybe I'm going to ask the study team later. Yes.
So these are the open rocket design. Basically, it's a mechanism that I've just mentioned about. So the first motor that they have given us was the P135. It's managed to get us to 2230 meters apogee. However, they changed the design to the 143. It got us to the 28 or 9 meters that we are currently working with. So what we are yet to accomplish for this week is come up with the bill of materials and finalize on the launch pad design. So we had already presented the launch pad design in a script. However, the town told us to think the design, so it's wouldn't work. So yeah, right now we want to redesign that maybe to make that thing.
Yeah. According to our preliminary design, or we are the current on very careful things, because we are serving them, the ones team and also from the final rocket design the airplane, we're going to design the diameter and the length of the launch rod, because we noticed that since we're using the rod, initially we were thinking about using a rail for an airframe of small thickness. It will not be possible to make adjustments use the rail. So we use a launch rod. The issue with the launch rod is determining whether it will be stable to hold the airframe in place before takeoff. So we are researching to determine the type of material which will be strong enough to hold the the airframe for launch. And also we are researching the last data material, the shape of the data. Basically, we're thinking by the end of this week we'll be done with the design.
Okay, thank you.
So for next week, this is what we want to have a shape. I think I've forgotten something. They just also want to do the printer on this one. We are thinking of bringing it out in the printer for one of the reference. Yes. So it's already done. So next week we want to start predicting the unit play and see how everything is in collaboration with the unit play. Then we first started into the fiber lab. So we had a question of whether there are units of the fiber materials, or are we required to like create a new patches of the thing?
So do you require to purchase the resin and fiberglass?
Yeah, so we didn't know how to proceed that because we knew that there are some news already here.
Oh, okay. Maybe, I think your question is concerned about the process of purchasing. Maybe I can remind you or entire team how to proceed. One, you make a list of the items you want to purchase, like the name, other materials. So I can send you M-Pesa. So one of your representatives can go to the shop and make a purchase. Then you can ask me the amount you want. Then I can send you, or I can send directly to the shop so that we can make a payment. Then bring the receipt to me. And as I mentioned, there is a Google form. I think it's written on the orientation slides. On the Nakuja, yeah, there is a top page. Sorry. Seems the internet is not working well. Okay, so now I was looking about, there is a slide. Oh, it is not here. I need to put the link. But anyway, there is a receipt uploader. So once you make a payment, you need to fill in the information and upload the photo of the receipt. But still, you need to bring the original receipt to me or to my office. Okay. So that is a procedure. Is it clear? Yeah. Okay. Now, let's go to yes, please.
Have you considered maybe estimating the COD position?
We're currently using the estimate given by the end of the simulation.
Which is the COT and the COP. Because I would also influence
So basically, they are calculating the stability using the open rocket simulator. And now, okay, another just a quick question. You said you're 3D printing the airframe. I mean the avionics bay. Which part? Here or everything?
Everything is really
Oh.
But for the white part, the road. So for the road, we had two options. One is to repaint it, but to make it stronger, we increase the meshing. while printing, or two, we get rods of that specific size to hold everything now in place.
I see.
Yes.
Okay, so my suggestion, I think instead of 3D printer, why don't you use a laser cutter and cut the acrylic board? How much is the thickness here?
2 centimeters.
2 centimeters, 20 millimeters.
Yeah, 20 millimeters.
In that case, because our laser cutter upstairs can cut the acrylic board 5 millimeters. So we cut, so we create 4 pieces, then combine to create a 22 centimeter component. Because it sounds a 2.5 dimension, 2.5D component, meaning it's consistent in z-axis, right?
Yes.
So in that case, I think the fastest way is to use a laser cutter. But if you have any complicated 3D shapes, you can, yeah, it's better to use a 3D printer. But you know, disadvantage of 3D printer is very slow. It's very slow. So yes.
Huh? This side again. 40. Yes. What is with is concurrent to the airplane. So 70, 79 statements. No, the avionics should be 80. More or less, if you want it to be tight, using one statement.
So there is 1 millimeter clearance.
But we will hold it to the.
She wants to say something.
I don't know. I feel like 1 millimeter might go through the same problems we went through last time. There's very tight fits. So then don't quite having trying to stay. I'm not sure what I am suggesting, but if it's too tight to fit, it might go yet another. In the process, you might think they actually need a thing it might be there or bring some of
So you can some after preaching concussion, you decided to see it is still that we can start out the outer there and the outer the part that stretches the tube, you can send it out and then it is
that's good. Another one fine is where you say we don't get parts assembled from your thing, it's a lot of people have to use so much. It's very sensitive to PS and it's very susceptible to rules, like for instance, if they need to and then it doesn't actually connect. So my concern is if you use styrofoam to then create a shock absorber, we might use things up. We might fail to connect
what is the reason of this section? Why? I'm wondering, is this why this is not working properly?
We have tried to connect. The concern was we were using capacitance. That's the capacitance. It stays quite alright to connect. Just how to we use styrofoam that we are creating the resources.
Okay, maybe we need to benchmark, but how about putting the antenna outside the rocket or attach it on the surface of the rocket? Is it possible?
This is possible. We can just
Yeah. If you don't want to contain the sensor inside, maybe you better think about exposing.
My final concern was we've spoken about designs. It's too able to meet the distance we have to then come out and present whether it's not even verification and the party. I think it's going to be easy.
For the most part, I don't think it's really much affected because the fact that we get into this drive and so we want to research. So we don't really affect what they are going to do how to future that project. And so you can plan with GPL system, we have that option we have in the answer and also the other. So we have to make that okay, but the last time we checked it was using the last component from the outside.
That is not specifically just for the energy, but in energy. So the GPS will be still in the exam.
So we have this outside then if that was.
So please try to cover this kind of discussion while we are discussing. Okay, let me add something. Because if I focus on this, I cannot proceed with following session. Yeah. So please do. Anyway, the appearance. Something outside. This razor. Okay, so yeah, let me quickly go through the whatever task sheet. So airplane team, yes, I think you are listening well. So as I mentioned, you should remove or strike through, which is something you have done. Okay, yeah. And Gantt chart. Where is your Gantt chart? Yeah, can we see it now?
Yes. Yes.
Thank you. Oh, okay. So this is your Gantt chart, right? I don't see any how to say timeline.
This one.
This is not. Oh, Innocent is saying they can be found on an Nakuja internship airplane. Let me check.
Is it possible to open that with Google with Excel sheet?
Yeah, no problem. Yeah. Anyway. So okay. Right now, it seems you completed your internship.
This is not the opposite of
So,
Yeah, do you know what I mean? Yeah, you have something in the future. You need to indicate which task you are going to work in which week, something like that. So I think please modify and update the run chart and share, right? Okay, maybe it's okay for now. I just wanted to clarify that you are doing the right thing for the last week. Okay, you have to do something which is indicated in the task chart. Otherwise, you are doing something else, right? Okay, let's proceed. Solid team, Shabab and team, yes. On GitHub? Discord. Oh. Yeah, oh, just a moment. Something is wrong. Yeah, but anyway, yeah, we can proceed.
failure to understand let me translate it. So the sound we can do that same effect. In the water to determine all this function and your pressure, which is a pressure, the pressure, how long the ability of the water.
There is a figure here, so you can speak out.
So there are three design concepts to consider to understand. There's the horizontal where we have motor, where we have a motor horizontal, that should be the stand. That is somebody design. We want to use the one. And we also have the option of configurating stand with the user of picking up. That's the development, that's the one we can do. We also have the kind option, result facing down, the integrating one facing down. Now everybody kind we divided our team. So today we want to determine you are actually, according to the very much keeping of this, you should consider the safety, the safety of the system, and considering the people, and also the evidence base. We're also considering the complexity of the design, because we know we don't have much time. We're also considering the availability of the materials and how to design the design. So today we want to learn, them, we have finished them, then we people in the team. So this week we want to design, and then models, and then we continue for discussion because we feel like we're taking more time than understanding from last week we finished working together in the water, so communication with our team, the program. We already identified areas to source materials for the water except the casing. We've only been finding about learning from basically the casing. We can so really have the idea that we drill and then It's good.
Have you completed the design of solid motor? Yeah. Do you have open motor simulation file? So GitHub, which one? Sorry, focusing. Is it open motor files?
So we did two simulations.
Mhm.
One is in open motor and the other is in science. So it's an Excel spreadsheet.
Spreadsheet.
Yeah. Most of them are there.
Let me check. Excel sheet.
Yeah.
Excel files. It's all right. Okay. Yeah, I think yeah, you have used the Excel. Okay, yeah. Then
So initially we were using 4 cartridges. That was plus one program but that was before we understood what the other things were doing. So then we got the information that the FM team were considering aluminum. So we had to put into considerations, into consideration their weight. So we started with assuming thickness of 2 millimeters for their side. We calculated the weight using aluminum 6061. Then we asked the company team for their approximate weights, and that is why we added another cartridge to become very cartridges with motor movement 1 plus from K to so and also from the second spreadsheet, we got values for our ideal velocity, which is on the nozzle design tab.
okay, well. Do you remember the maximum pressure for N2 motor? 5.4. Okay. So you are it's 8.5 now. It's increasing, right?
Yes. But yes, the pressure has increased, but the also the we accounted for the pressure because we're using a 3.5 peak. A 3.5 millimeter.
Wall thickness is a 3.5.
Yeah, aluminum 60. The weight is around 1.2 kilograms, which is accounted for. So the total weight from our side is about 6 kilograms. When we take that 6 kilograms and we add it to what they gave us, they gave us an open rocket file, which they said it was probably used. So when using aluminum, the total weight will come to 2.6 kilograms. And the company to achieve that point is, it was less than what you guys did. It was around 23 meters.
So after you optimize your design, that's when the items increased. So if you give us the design, we will be able to go to a lower class so that we can increase the value. If you send the overall design, that's the overall design that. Essentially, this is the one that you are still using. The only thing that changed the water design. The water design that I have now is L1.3. L1.3 is that the one that you're using? Yes. Yes. The mass of the water is 4.674 kilograms. And now, and the mass of the water is 9.9 kilograms. The water you have is 6 kilograms. It's way higher than the one that is already higher. Here, the one you have is 5 something kilograms.
In your calculation for rates, you not accounted for the testing of the loss range. That is approximately what we get when we take into consideration the mass of the coconut and say yes, that's it. But ukiongeza zote inakuja because you're using a steel bus. Actually, if you check out intern, you will see
the reason the end will give us. So we believe that we're going to create an Excel file that we can upload, that we can put all the specifications, and those will be the set specifications we want to get off from them, so that you can rest assured we won't change anything. I believe that's a better way, so that anyone who is there, units that anyone can think that we want to also, I think they saw the designs and they will also you can do this one. We believe that we have submitted over the trust, knowing that we want to make sure the amount of data that we need to reach 2,000 meters. I want that there's something that if the values are not going to change, we will need to go back to open water and possibly reduce the weight.
Actually, you can propose we have some meetings there. So
Yeah. I think you should communicate well, because I think my intuition is this solid rocket motor is way above of our expectation. So I think we should sit together and discuss. Then I just wanted to see. Oh, it is not showing full.
And run the situation.
Yeah. Now, again. Okay. Yeah, it's okay. So yeah, that is basically my comment. And quickly, I want to go through your tasks.
So the gunshot is on the meeting minutes of the last week.
Let me see. 10 minutes of last week is Nakuja second week.
Yes, we are opening the link.
Sorry, propulsion, this one.
Yes.
Yep. Okay, maybe you can generate PDF. I think let me try. Oh, is it? Oh, yeah, it's visible. Now you are here, and the task you're working on is static test done. But anyway, you still need to finalize the design of the motor. So please adjust. And okay.
Also, before you left, you were promised to run increase the amount of programs that you and we just getting back to us with the purchase.
I have 4, like 2 kg of potassium nitrate. Yeah, so you can just come to pick up. Yeah. Oh, by the way, I'm not going to get back to you because I will be always reminded because so many communications are there. So you shouldn't wait for my response, okay? Yeah, I think, yeah, and one of the findings is that maybe you should complete, the solid propulsion team should complete this task sheet because there are some empty information. Yeah. So please describe the information. All right. Anything else? Okay.
Last week, there was supposed to create a team who is coordinating issue. The team is created. So we will assign the people who will coordinate each of the groups.
I see. Yes. So there are team leaders, right? So team Sabak, Edwin, and Avionics, is it? Sorry, airframe is innocent. Yeah. What else? Liquid 4. So you can always communicate. And since you are here always, it's easy for you to. You don't need to work in island. Okay, you should you should go across the ocean. Yeah.
With regards to that, let's take example an example where we detail, I think it's in this code, Jennifer.
It's called which one?
Jennifer.
General.
The one standing.
Oh.
That one. I think it's detailed on so that everything could know what has changed.
Very good, very good, very good.
So people are expert. They can do the for the overall system management.
Yeah, that is something we need. Okay, so let's utilize. Who proposed this one? Oh, very good. I appreciate. Okay, finally, the liquid team. Please go ahead. Liquid propulsion, week 3.
You can go to the objectives of the and such. So those are present. So for objectives, we first start with then a space as the one that was used in the previous group. We had to modify the course. We had some previous challenges such as communication between the register and they are the register and the computers they were using. There also some parts that we require. For the coding test, we also had to work on the software part and the hardware part. And there is the application to so that you can integrate all of that. The communication, the control, and everything has for the app control, the cylinder control should be part of the software. So for last week, we were able to not only present the blueprint, we also printed it successfully, and we are able to repeat it. Repeat it in the conversion chamber and repeat it. So we decided to use the 3D printer first, so that we were sure the dimension before we actually use the actually is the type of so that you can consult and the source. For the software, since we're using new sensors, we have to modify it, and also they said previously the previous some challenges which we have some challenges which are in the so we were able to modify the software and know that it's required nice is to test it. The parts acquisition, we were able to apply the we were also looking at the parameters where since the parameters for the previous team must have had a very narrow range, so we had to start looking for new one. For both gas and liquid, we used both the cooking test, in both the firing test and the water test. The major challenge we faced is that most of the parameters abroad, and we are able to look at the cooking. We settled the activity. For the microcontrollers, we decided to use the Pikachu now because of this which is what Wi-Fi enabled, which makes it easier to communicate with, and thus we can communicate with it remotely, actually go to the test which and that's the same. Now all that is left is we will apply the skills and skills. The last thing, the fully test we started working both for control of the products and acquisition of data. Then I'm going to the next slide. And the hardware part, we already worked on the software part. The hardware part we are looking at the required to use. This is mostly for the water test that we production required to take the water. We started by looking at the characteristics of the well so that we can relate the existing test and the data we acquired We have looked at how the coil starts. Looking also at the limits, we are able to achieve a temperature of 67, and we have to stop. Since we are using the coil in the combustion chamber and going further, we can destroy the combustion chamber. But this is the qualification. We are running at the limit such as the start of the
Just a minor advice. If you mention temperature, add degree Celsius or Kelvin to indicate degree Celsius. Right, thank you. The same thing applies to your team. So let me check the tasks. And maybe the projects. Function. Yeah, I think it's covered. And rigid propulsion. So briefly report, summarize what you have done here, what you have taught. And propulsion, yeah, I think you are listening very well. So where is your Gantt chart? GitHub, internship. This one. Right. So now we are around here. Now seems you completed the preliminary research, design some components, prototyping some components, 3D print. Have you completed?
It's related to the space.
Yes,
Yes.
it's completed.
Yes.
Oh, anyway, I forgot important things. So you're listing that code tasks like this, right? It should be synchronized. This one and this one. Yeah. So I was just wondering where is this prototyping of subcomponents, but it is this. It's okay. Well, basically it is synchronized. I think it's okay. So you're saying you are going to test the water test from 20th February.
The low pressure, for the high pressure, we still have the first of all, balance. What we need, we set it up and put up the sensors for the mechanism. Such as what we for the capacitors.
Okay. Acquiring new sensors. So how is the progress?
So we've been able to see, we've been able to do research on the ones we need, but still cost. The cost is the one that's actually
Okay. I see. Okay, so far so good. But in case of maybe this one is announcement for any teams. So in case of any challenges, please let me know. We can have set a meeting in addition to this meeting, okay, team by team. So please let me know if you have any challenges. You don't need to get stuck. So please consult me first. Yeah. Oh, now my battery is low, so I want to wrap up this meeting. The time is almost 2 hours. Do you have any other business, AOB? Please.
There's something from the vision of the previous project. someone property land. So we wanted to design and fabricate another jig, which will be a useful asset in the current future. When land is finished.
Okay, thank you for the report. Something else is that we want to make this meeting to keep it short, like 1 hour. Okay, so your cooperation is appreciated. So what kind of cooperation? So please, maybe you can extract the essence of your achievement for the week, and which should be aligned with the Gantt chart or your timeline. Okay, because basically we want to check if something is wrong. Okay, so basically you don't need to hide the challenges. So maybe I want to ask you is to highlight the current issues, challenges, or I don't know, complaint or something, so that we can solve that issues. Okay, and because if the meetings takes 2 hours, maybe most of the members get bored and start something else and not hearing what others are doing, which is wrong. So because this is an information sharing session, so everybody must hear what others teams are doing, because we are separating into the several groups, but we have to work together. Okay. The purpose of splitting team is not splitting the information. Okay, we have to aggregate all together. So, for example, what I mentioned is that please cooperate for taking a memo, because if the airframe team is reporting, maybe they are busy for saying something. Okay, so that other teams can capture what is discussed, right? So your cooperation is appreciated. So, okay, thank you very much. Any final comments? I think yes. I think I have seen only one receipt uploaded. Meaning you are not familiar with process. So as I mentioned, you can purchase whatever you want. So please consult me. Can be tools, a soldering iron, anything. So please consult me if you need anything. So. Thank you very much, and see you next week. By the way, I will see you this week. So it is good for you to work here, because I occasionally come here. Ideally, I want to pass by once a day or more to interact with you. Okay. Yeah. Thank you.